Alright, hello everybody. Welcome back to another edition of Algebra 2. Mr. Anderson here with you. Today we're in section 4.7. We're going to talk about some transformations of quadratic graphs, which primarily is going to be dealing with vertex form, what we call vertex form today. Alright, first of all, before we start, here's what I got today. Winter Park t-shirt from the ski trip. Oh, sorry, juniors, you don't get to go to the ski trip this year. Oh, all right. Well, anyway, sorry about that. Let's talk about our objectives first of all, okay? First of all, we want to write a quadratic function in the form of y equals a, parentheses, x minus h, parentheses squared, plus k. That should look somewhat familiar. That's what's called vertex form. We're going to talk more about that in a second. And then transform graphs of the quadratic functions in that same form. Okay, so those are a couple of objectives today. All right, vertex form. Here's vertex form. If you didn't write it down before, write this down. Y equals a, and then parentheses x minus h, close parentheses squared, plus k. That should look kind of familiar. We've talked a little bit about this before. In this form, h is the x value of the vertex. So if that was x minus 3 in the parentheses, 3 would be the x value of the vertex. And then k is the y value of the vertex. So if that was plus 4, then the y value of the vertex would be 4. And this should look somewhat familiar as well. Remember, we've been talking about the axis of symmetry, where you have x equals a number. That number that x equals is h. You know, whatever's in the whatever is in here. So that's going to be your axis of symmetry. X equals whatever that number is. And then a is that number out front. It's going to determine the shape of the parable, how wide or narrow it is, and then also what direction, if it goes up or down. Remember, if it goes negative, you know, if it's negative, it goes down. If it's positive, it goes up, and we'll talk a little bit more about that in a second too. That's kind of the general stuff that you need to know right there. All right, so here's an example of what we might do in our homework. All right, we're given an equation here. This is a quadratic equation, but it's in standard form there. It's not in vertex form. And so how do we change this into vertex form? Well, there are some other ways to do this, but what we think is kind of the easiest is let's just find the vertex, and then we can plug in the numbers. So here's what we do. Remember our good old friend here back from a few lessons ago, x equals the opposite of b over 2a. Remember that? We're going to use that again. All right, so we're going to just plug stuff in here. And so in this case, b is what? 6. So this is going to be a negative 6 over 2 times a. A is 1. So this is going to give me negative 6 over 2, which is really just negative 3. Now, what is that again? That formula tells me the axis of symmetry, but also what's the x-coordinate for the vertex. So this number that we just found right here, that's our x on the vertex, which is one of the things we need to know to write vertex form. One more thing we need to know is we need to know what the y is at the vertex. So all I have to do is take this negative 3 here, and let's plug it back in for these x's, and then when we solve all this stuff here, we'll know what the y is that goes with it. So this would be y equals negative 3 squared plus 6 times negative 3 minus 5. So let's just work all this out. That's going to tell us the y of the vertex. So negative 3 squared, 9. 6 times negative 3 is negative 18, and minus 5. And so then 9 minus 18 is a negative 9, minus 5. It's going to be a negative 14, it looks like there. And that is the y of the vertex. So what this means is our vertex, I'll just kind of write this right in here, our vertex, we just figured out that the vertex was -3, -14. So what we're going to do is we're going to use that to write the vertex form. Now remember the vertex form again, I'll write it down over here, y equals a times x minus h squared plus k. And so let's go to write this here. We got y equals a. Ooh, you're like, ooh, what's a? Well, remember in the standard form here, a is the number in front of x squared. Well, guess what? In vertex form, a is the same number. So whatever number we had here, this was 1, it's going to be the same there. So it's 1, and again, since it's 1, we don't have to write the 1's in there. We can actually drop that. But if this was 2x squared, then we would write 2 out in front, and so forth. So in this case, though, we'll drop that 1, and it's just going to be x minus, what's h again? Minus a -3. So remember, minus a negative makes it plus 3 squared, and then plus k, which is plus a -14, so we could just say minus 14. So that would be vertex form for that equation. So basically all we're doing is using this little formula to find the x, plugging it back in to find the y, and then we just plug all those things into the vertex form. Okay, let's take a look at another one. Here's another one, a little trickier because we have now a -2 up here. But let's go through the same steps. So let's find the x first of all. So x equals opposite of b over 2a. Opposite of b is -8 over 2 times a, which is -2. So this is going to be a -8 over -4. Negatives cancel. 8 divided by 4 is 2. So this is 2. Our x on the vertex is 2. Let's plug it back in. So now we go y equals -2 times 2 squared plus 8 times 2 minus 3. Let's work that out. Remember order of operations. Please excuse my dear Aunt Sally. 2 squared goes first. That's 4. So it's -2 times 4, which is -8, plus 16 minus 3. So you have 16 minus 8 is 8. 8 minus 3 is 5. That's the y of our vertex. So that means, and again, we're just trying to write the final equation here, but just to kind of refresh your memory, that means the vertex is 2, 5. That's the point of the vertex. And then to write the equation, y equals a, remember, oh, a, but now we do have a number here, so we're going to write that, -2, parentheses, x, remember 2, so it's going to be x minus 2 squared, and then 5, so it's going to be plus 5. So y minus 2, parentheses, x minus 2 squared plus 5 would be our equation there in vertex form. So remember the vertex 2, 5, you just plug those numbers in here and here, and then a, which you get from up here, you just plug in there for a. That's all you do. All right. Example 3, now we're going to graph this. Now this should look pretty familiar because we've kind of done this before. So this shouldn't be too bad. Remember, when you go to graph these in vertex form like this, this is where this number out here, remember, tells you to move up and down, from the parent graph. And this number inside here tells you to move left and right from the parent graph. So this one should be pretty easy, especially since there's no number out front here. So this -4 tells me that from that parent graph, which remember starts at 0, 0, and it's going to make a U shape there, we're going to go down 4, right? So I'm going to go down 1, 2, 3, 4, and then I'm going to go Now, if this is -3, remember that's where we go opposite, so it's going to be a +3. So we're going to go down 1, 2, 3, 4, 1, 2, 3 to the right. You know, which, by the way, when you look at this, that should make sense as well, because remember the vertex here is going to be, since the formula said x minus whatever this number is, that the vertex there is going to be 3, -4. And you, what did we do? 1, 2, 3, 1, 2, 3, 4. 3, -4, that's the vertex. We just got it right out from here. So you can either think of it as moving from 0 to wherever, or just think of this as what is the vertex, what are the 2 points, and then put your point there. Once you got the vertex, and by the way, just a little side note here, remember the axis of symmetry? You know, it was x equals whatever h is. Well, what's h? H is 3. So your axis of symmetry is 3. That means there's your axis of symmetry. Great. Okay. Then to finish this off, you just want to find the other points. You know, make a little table and find the points. So I would suggest going on your calculator. That would make it very easy. Hit the y equals button. And then you just type in, again, use the parentheses, you know, use your parentheses. Where's my thing there? Use your parentheses here. So you're going to go parentheses x minus 3, close parentheses, squared minus 4. And again, you could hit the graph button to kind of see what it looks like to help you with that. But the important thing is do second function table to look at the specific points that you've got here. So I'm just going to write them down here. Remember our key point here was where x was 3. So I've got 3, -4, which comes up on the table. Interesting. Okay, it's the same one. And then I've got 4, -3, 2, -3, 1, 0, and then on the bottom side 5, 0. So we'll just plot these points here. 1, 0, 2, -3, 4, -3, and 5, 0. And you see kind of what it looks like there. And then let's go ahead and graph that. And there's our graph. And since there was no number out in front here, you could have kind of remembered the general shape of this graph, that from the vertex it's going to go, you know, up 1 over 1, and then another 1 and up 3 from there, if you kind of remember that pattern. But if not, you know, just do the chart here on the calculator. Okay? All right, so now in this one, what we're going to do is we're going to take a look. Now, let me switch over here. All right, now in this one, what we're going to do is we're going to graph this. It's going to be a little trickier here because of this 1/2, but we're going to follow the same basic pattern on that. So first of all, we know that the vertex is h, which in this case is 2, and -3. So we can go to 2, -3, and plot a point. There's your vertex. And then remember, just a kind of a side note here, remember the axis of symmetry is x equals whatever number h is, which is 2. So x equals 2 is our axis of symmetry here. So that's good to know. And then just to find the rest of these points here, let's go to our calculator and punch it in. When you go to punch this in, if you wanted to do parentheses 1 and then divided by 2, close parentheses for the 1/2, and then the rest of it you could. Or since this is a terminating decimal, go ahead and you could also do 0.5 would be fine to do there. I think either way that would give you the right numbers. All right, so we're going to do that. And then Remember, you can use that graph function to see what it kind of looks like, but the more important thing is use the table function to see what the actual points here, so you can actually plot the points yourself. Use the graph function just to kind of double check your work. Now you do have some interesting things going on here. Remember 2 is the middle point, so I've got 2, -3, which matches with what we figured out from here. That's good. Then I've got some interesting things here. It's like 1 and a -2.5, 0, -1. And you go, ooh, you got a 0.5 here. And you can do that, plot those points best you can. If you wanted to, you can just kind of go up and find the next bunch of integers where you don't have the 0.5. And you could also have like a -2.5 up here, which is still on this graph, which wouldn't be hard to do. Going the other way, you've got 3, -2.5, 4, -1. Or again, if you go a little further here, you could find 6.5, you know, and forget the decimals here. But regardless of what happens here, then just plot some of these points to get a feel for what this is going to look like. So from 2, -3, we could also do 1 and -2.5. Might be a little harder, but it's somewhere about right there. And then you've got 0, -1, which is about right here. And then you've got 3, -2.5, about right there. And 4, -1. So that could be enough to do your graph. If you didn't want to do those 0.5s in here, and you wanted to do -2 and 1, 2, 3, 4, 5, you know, put this pointing up here, and 1, 2, 3, 4, 5, 6, 5. If you wanted to use those instead because they're not, you know, 0.5s, that's fine. It's still all in the same line there, just as long as you have enough on each side to kind of get a general feel for the shape. And there it is. So that's what that equation would look like once we graph it. All right. So remember, little review here. This is stuff that we've talked about before, but just a little review. Again, when you're graphing these, you know, you can use the calculator. You also can use what we know about transforming or moving the functions. So remember here, the h inside here, remember this h inside right here, that will move things left and right. That's a horizontal translation. Remember, what it's always kind of opposite of what's inside here. So if it's -3, that means you go 3 to the right. Or if it was +3, you'd go 3 to the left. So just remember that one's opposite. The k here, that's out on the end, remember that moves things up and down. Plus k moves it up, minus moves it down. And then remember the reflection that's on A. If it's a negative, that flips it down. And then A, the dilation on A is going to either make it wider or narrower on the graph. And so just remember, you know, again, I would suggest typing this in your calculator to find the exact points here. But just remember, if A is bigger than 1, like if it's 2 or 3, it's going to stretch it, make it skinnier. And if what's in front of the A, you know, if the A there is like a fraction, 1/2 or 1/3, it's going to make it flatter and shorter, kind of more like this green one here. So just kind of a review on those things, just to remember how those work. And then last one here. There's be a few problems that you'll need to work where they'll give you a graph like this, and then you'll have to write the equation from it. Okay, so and usually, and I'll just kind of set this up here. On this one, it doesn't have it, but usually on the ones, they'll give you another point, like right here. See this point right here? That's the point of 0, -1. Usually they'll give you that, so you don't have to guess at it. So we're going to use that point because that's going to be important. All right, so remember our vertex form again. Y equals A times x minus h squared plus k. What do we need to fill in here to write an equation? We need h, we need k, we need a. All right, well, what do we have? If we look at this, we can find the vertex. If you look here, here it goes down, 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 down. Boom, there's the bottom right there. That's the vertex. What point is that? That's the point of 2, -3, it looks like. Okay, so 2 on x, 1, 2, 3 down on y. So we can fill that stuff in here. We know that h is 2. So it's going to be x minus 2 squared. And then k is -3, so it's going to be plus a negative or minus 3. Now, there's one thing we're missing. It's the a. That's the one thing. So how do I figure out what the a is? Well, that's where this other point comes in. What we need to do to find this a is we'll take this other point. Remember this other point, it's just some random x and some random y. In our final equation, we want to go back to x and y because there's a lot of these x's and y's that get used. But we can temporarily plug in this x and this y, the 0 and the -1, for this x and y here, and then all we have left is a, and we can solve for a. So x is 0, so I'm going to plug in 0 here. A is what we're trying to find, and y is -1. So we're just going to solve this equation now. 0 minus 2, -2, and we square it. -2 squared is 4, right? So a times 4, or 4a. Oops. I'm going to rewrite this here to make this look better. That's really 4a minus 3 equals -1. And now it's just solving an equation like we've done, you know, hundreds of times. Plus 3, plus 3. So you have 4a equals 2. Divide by 4. So it looks like we've got that a equals 2/4, which would reduce to 1/2. And so our final equation here, y equals 1/2, parentheses, x minus 2 squared, now, plus a -3. I would probably write minus 3, but I wrote plus there too quickly. So that's the pattern on those. Find the vertex to plug in the 2 and the -3 into the form. Find the other point to plug in for x and y, and then you'll solve for a, and then you'll go back and you'll plug in a and take the x and the y and move them back to x and y. Okay, so that's it. That was section 4.7. Thanks for joining me, and I'll see you again in a few minutes in 4.8a, just the first part of 4.8. It's going to be really short, so I would suggest go do it right after this and just knock it out. It'll be like 5, maybe 10 minutes at the most. Real simple, and should be pretty easy too. So thanks for being with me. We'll see you next time. Bye.